Okay, so welcome, and now we'll do a couple more examples. Now this is dealing with the calculator because obviously looking at these numbers, these are not going to be numbers that we're going to be able to use the unit circle to get us the answer. So this is where we're going to have to use the calculator. Okay, so, and in this case we're going to have to use inverse sine here, right? So we can set it up by taking inverse sine on both sides, and then that'll give us theta is equal to inverse sine of 0.8. Okay, now notice that this is positive, right? By the way, this is a ratio, so this is in radians, so make sure your calculator is in radian modes. And then when you can change it to degrees when we have the angle. Since we're dealing with a ratio, we want to have our calculator in radians, and then we can convert to degrees later. That's what I was trying to say. So now what we can do is we can do this in our calculator, but notice that sine of theta is positive, so that means this is going to be in the first or second quadrant. Okay, so we're going to have two solutions, right, that will give us 0.8. There will be two solutions, again, assuming 0 to 2 pi. Okay, now the calculator will always give us the positive angle. Okay, it'll either give us a angle in the first quadrant or the fourth quadrant because we're dealing with inverse sine. Okay, so let's get our calculator. And oh, I don't have my calculator with me. I left it inside. Okay, so let's do this. So I am going to look at the answer here. And so the answer that you should get is approximately 0.9273. Okay, so now how do you do this? Well, I've showed you before, but remember there's an inverse key on your calculator. It's usually this above, well, there's not an inverse key, but there's an inverse function, and it's usually above the corresponding trig function. So your key would be a sine key, and then you have above that written or typed, it would have inverse. It would have this above it, and then you would use your second key, right? So you do second sine key, and it would give you your inverse, and then you would put in 0.8, and then you should get 0.9273. Okay, now this is in radians. Okay, so this is the measurement in radians. Now notice that this is in the first quadrant. Okay, because the, 90 degrees is the same as pi over 2, which is approximately 1.57. Right? So pi over 2 is approximately 1.57 radians, right? And then pi, or 0, right? Obviously 0. So this is greater than 0, but less than pi over 2. So we're in the first quadrant. Okay? So if you put your calculator in degree mode, and you can convert the angle to 53.1. So this would be approximately 53.1 degrees. Okay, now the other angle, right, like I said, the other angle is going to be in the second quadrant. So to get the other angle, you would have to take this angle and subtract it from 180 degrees. And so if you take 180 degrees, so 180 degrees minus the 53.1 degrees is going to give you, what? It's going to give you 126.9 degrees. Let me confirm that. Yes, approximately 126.9 degrees. Okay, so those are the two angles. So your two angles that would give you this ratio are those two. So now what about this example? Now here we have a secant function. Okay, so here's what I'm going to do. I'm going to use the reciprocal function. So I'm going to write this as 1 over cosine theta is equal to -4. So that means that cosine theta is equal to -1/4. Okay, now here again, it's another situation where we're going to have to use a calculator, right? Because this is not going to give us a nice triangle that we're used to using. Okay, so what I'm going to do is again, I'm going to take the inverse cosine of both sides, and that's going to give me theta is equal to cosine inverse of -1/4. Now, since, well, let me think. Now, since cosine is negative, right? So which quadrants is cosine negative in? Cosine is negative in the second and third quadrant. Okay, so we know that the angle we're looking for is going to be in the second and third quadrant. Okay. So now all we have to do is use your calculator, and again, I don't have my calculator, but again, you're going to use the second cosine key to get the inverse function, cosine inverse, and you're going to get 1.8235. So this is going to be approximately 1.8235. Now, give you an idea, okay, where is this located? What quadrant is this located? Well, it's bigger than pi over 2, right? But pi, now where's pi at? Pi is approximately 3.14, right? Well, this is definitely in between pi over 2 and pi, which means it's in the second quadrant. So now if I change this to degrees, again, this is in radian mode, right? So this is radians. So if I change this to degrees in the calculator, then I'm going to get, oh, wait a minute. They want us to do it in radians. Okay, so they don't want us to do, so they want us to leave it in radians. Okay, so now, guess what? This is radians, right? So that we know this is in the second quadrant, so now all we have to do is get the 1 in the third quadrant. So all we have to do is take this and add it to pi. Or no, I'm sorry. Let me think about that. So this is in the second quadrant. Okay, so let's draw it out. Let's draw it out. So this is in radians, so we know we're in the second quadrant, so we know that we're somewhere over here, right? So this is theta. And so theta is approximately equal to 1.8235. So that's our angle, okay? So, how do we get the other equivalent angle? Like there. So we need to get the other equivalent angle to here. That gives us the same reference angle, right? So it gives us the same reference angle, alpha and alpha. Okay? So, how do we do that? Well, what we can do is we take 180 degrees, or pi, and we subtract off this to get alpha. And then all we have to do is add alpha again. Right? So we can figure out what alpha is, and then all we have to do is add twice alpha to this to get all the way around to where our other angle is. So let's do that. Okay? So what do? We take pi, which is approximately 3.14, 3.14159, so I'm going to round that to 6. Okay? And so what I'm going to do is I'm going to take this and subtract off 1.8235. And so what I'm going to end up getting is $1.3181. All right, so that's alpha. All right, so I just found alpha. Now what I'm going to do is I'm going to take double this, right? Because I want this angle here, but I want to go double alpha to get over to this angle. Okay, so now what I'm going to do is I'm going to double it. So if I double it, 1.3181, oops, let me do it over here, because I think I'm getting too low on the board. Okay, so what I'm going to do is now I'm going to take this angle, and I'm going to double it, 1.3181, okay? And of course that's going to give me 26362. Okay? Okay? And then I'm going to add that to my angle. So it's going to be theta plus this, which is going to be 1.8235. And so my other angle is going to be approximately 4.4597. Okay. So now, what do I get? Well, they want all possible solutions, right? So all possible solutions, so let's circle the two solutions I have, right? So this is one solution, and this is the other solution. So guess what? My solution is going to be multiples of 2 pi. So my final answer is going to be for theta, or for this equation here, is going to be theta is equal to 1.8235 plus or minus 2 pi k, where again k is an integer. And the other one, so and theta is equal to 4.4597 plus or minus 2 pi k, where again k is an integer. And that's it. Have a great day.